This is our third Elixir conference in Europe, and I'm very glad to be here, especially because in January 2017, this year, Elixir became 5 years old. And that's counting from, when I did the first commit for what Elixir would be today. And you can go to GitHub and see the whole history, everything is there, and you can see the commits and you can see what happened. But what I believe not a lot of people know is that Elixir started a bit before that, right? Like I think 99.999% of the population, when they have a problem, their first answer is not, I'm going to create a new programming language, right? So there are obviously a couple things that happen, and I like to say a couple of points of no return, where you are trying to find a solution to a problem and then you can't find it, or you find something new that completely changes your perspective. And those points of no returns, they eventually led to Elixir. So if you ever see me give a presentation about Elixir, you probably heard this story. So if you go back to 2008, Rails 2.2 was mostly doing Ruby and Rails development, and at that time, Rails 2.2 was released, and one of the big things that came in Rails 2.2 is that Rails 2.2 is now thread safe, right? And this was really, when I first started to hear about concurrency and multi-core, there was already some pressure from the community because they wanted to get their Rails application, they wanted to put it into production, and they wanted to use it as many cores as possible in their production machines. So there was some work towards Rails for making Rails thread safe, okay? And today, when I look back at it, I look at it with a different perspective. So for example, so why thread safety, right? So in Ruby, if you want to use all the cores in your machine, you spawn threads, so they can each run on different cores. And thread safety means that if you want, you'll be able to get your Rails application, make it use threads, and your Rails application is not going to blow up, right? So today, when I look back, I find the word thread safety or something that is thread safe really, really funny, because that's the lowest guarantee that you can give in software, right? It's like, oh, it's not going to blow up. Imagine you being a software company and then a client comes and say, hey, which guarantees can you give to me about this product? And you say, it's not going to blow up. Is it going to be fast? It's not going to blow up, right? We need more, we need better guarantees, okay? It's definitely not enough. And I keep saying this, like especially, so I upgrade it every year. I have been saying this, I think, since 2015. But I say, like, in 2015, I would say, in 2015, we should be using your cores in your machine. And then last year, in 2016, we should be using your cores on your machine. And again, 2017 is the same story. You should be using all of the cores of the resource that is available in your machine. Like last year, Apple announced the new Apple Watch, and it had 2 cores. Like your wristwatch has 2 cores, okay? So we got there, we got to this point, okay? And and everything we do should be using all the cores, compiling your code, running your tests, okay? And we are going to be more productive because of that. But as I said, later I joined the Rails team, and I was working on, and sometimes would find bug reports. People would say, well, when I put up a new server and it's on high load, I start to see some concurrency issues, and those were very hard to reproduce, very hard to debug. And then at the time I was thinking, well, if concurrency is becoming more and more important, okay, we need to have a good solution for this problem, right? And then I started to see what are the solutions for doing concurrent programming. And on this path of searching for solutions, I think my first point of no return was when I found functional programming, okay? And there are a lot of different ways you can categorize functional programming, but for me, at the time, and to a big extent still today, functional programming is about having explicit state in contrast to implicit state, right? Because if you think about object orientation, right, one of the reasons we have object orientation is because we want to encapsulate state. So we have state hidden inside of objects that own other objects, that own other objects, right? We have this Russian doll of state. And it's really hard to reason about it when you're writing concurrent software, because imagine that you have 2 different cores running at the same time and they're trying to change the same state. It's hard to find those situations, okay? So I realized that, well, if I had this rule where I was making the state explicit as much as possible, a bunch of those issues that I'm really struggling to find and fix and debug, they would be much easier to do so. And not only that, right? Instead of mutating things, we transform them. So in Elixir, if you have a list and then you delete an element from the list, you don't mutate the list, you get a new list in place. Okay? So that was the first point of no return. Like, if I was using those rules, let's say, those guidelines, my software would not only be better for concurrency, but I think it would also be clearer. Okay? And then I started to look more and more into other functional programming languages. And I started to get books, read about everything those other languages could do, what were their pros or cons, the benefits. And there was one book that helped a lot with the process, which is 7 Languages in 7 Weeks, which is kind of an introductory book around the different ecosystems and the different languages. But from there, it really helped me, to compare those languages side by side. And Erlang really stood out. Okay? So that was the second point of no return. When I was done with that book and then I started to study more and more Erlang, I was like, the software that I write, I want to run on this virtual machine. Because while a lot of people were focusing about concurrency, Erlang, for them it was like, no, concurrency, it's a solved problem. We are worrying about distribution. So while everyone was thinking, how can we use the resources of this machine as efficiently as possible? They were like, well, at some moment, one machine is not going to be enough, and you need to start using a lot of machines to work towards whatever you're doing, to work towards this common goal. So we need to consider distribution. And they did that in a way that we use the same conceptual model, which are processes, for doing concurrency and distribution. So it has this unified view, which I found beautiful. Okay? So, and then I started to work more with Erlang, study more, and I like to resume this initial experience with Erlang that I loved everything I saw, but I hated the things I didn't see. So I was missing ways of doing metaprogramming. I was missing ways for doing polymorphism. I was missing first-class Unicode support and other things like that. And that when I had this idea, well, what if I try to create my own programming language that is going to try to solve those issues? And that's when it started. So it started at the very beginning of 2011. And here is the commit graph. So you can see the commits. So this is 1 year before the Elixir that we know today, right? So here you can see the number of commits throughout that year of 2011. And that's when we started. And you can see that at the beginning I was really very excited about this idea, right? Like there are a bunch of commits, okay? And about April 2011, which is when the number of commits started to go down, here's how Elixir looked like, okay? We actually had something called def object to define objects. So it was an object-oriented language, right? It used a prototype object model, okay? The way I did metaprogramming at the time is that I used eval everywhere. So I just passed strings around and I was used to evaluate them, which is a stark contrast with Elixir today. Like in Elixir today, if you're calling eval, you're probably doing something that you should not be doing, right? It's completely the opposite, right? And then, so what I was doing here at the time is that I was just adding things on top of things. I was not really leveraging the virtual machine, the Erlang virtual machine and the Erlang runtime. So it was slow, it was extremely slow, and it didn't play well with Erlang at all, okay? So we can say that, Elixir, at that time, we can say it was a Wookiee mistake. No, didn't work. All right, okay, so I tried. When Jim said that it was a Star Wars Day, I actually went to a web page with Star Wars puns, and that was the one I liked the most, but. All right, okay, so Elixir as of April 2011. We can see here that as a result of this Elixir version, okay, we can see that in April, I stopped committing, okay? And I say that I reached the depression valley, which was the moment that I realized that this thing I was working on and I was excited about for the last 4 months, it was really, really bad, right? It was not good at all. And you can see that April was followed by a very quick spike in June, where I thought like, actually, I can make this work. And then I tried to make it work, and then I realized that No, right? I could not make it work. It had conceptual issues. And if you were, and I told this story at the first Elixir conference that we had in 2014 in Austin. Who was there? So, all right, a couple. That's great, right? And then I showed this image, which I think shows really well what was built in that moment. Is that I knew what I knew the shape. I knew what I wanted to get to, right? I knew that I wanted metaprogramming. I knew that I wanted polymorphism, but I had no idea how to get to there. So I was just like trying to fill in the things and trying to find a solution in whatever way I could. Okay. So at the end of this process, it came some positive things, right? I was able to understand that this is what I built, which is really important, right? I just didn't keep going on. And I was able to come up with Elixir Go. So you know what? I want this language to be productive because at the time we were already having discussions in the Erlang questions mainly saying, well, you know, someone that is coming to Erlang needs to learn about functional programming, he needs to learn about concurrency, he needs to learn about distribution, he needs to learn about fault tolerance. Okay, how can we make people that are joining the language then be productive, right? And there are a lot of ways, with documentation, having a good tooling and so on. So I said, okay, I want to be productive and I want not only the long-term productivity, but the short-term productivity as well. People should be able to have a good experience getting started. And then I said, I want extensibility. I want to have polymorphism, okay? And I want to have ways of doing metaprogramming so we can extend the language. And at the bottom here, the third goal is compatibility. And it's basically, you know, if I'm building this language because I want to leverage the runtime, I need to be compatible with the runtime. It cannot be slow. I should be able to integrate with Erlang, okay? And after thinking about this, we had the first big breakthrough after this moment that we stopped was something that I worked with Yehuda called Lago Lang. And the idea is, so here's the problem that I was thinking about at the time. Okay, I want to have metaprogramming, and it was clear that eval was a very bad idea. And then looking at other languages, I came back to Lisp again and to Lisp macros. And I say, okay, macros, the way we have in Lisp, they are really, really flexible, okay? But they're not enough because we already have two other Lisps at the time running in the Erlang virtual machine. And I did not want to create yet a third Lisp, okay? So I was thinking, how can we combine Lisp macros, okay, with a natural syntax? Let's say, you know, like Elixir syntax, right? And not only that, since macros are extremely flexible, how can we guarantee that they are explicit, okay? And the solution that we came for Lago Lang, it's very similar to how Elixir works today. So in Elixir, when you write something like add 1 and 2, internally, that is represented in the AST, that's represented with a node, which is a tuple of 3 elements, where the first element is the function name, the second element is a bunch of metadata, and the third element are the arguments, which in this case are the numbers 1 and 2. And then we said, okay, so that's the base language, and now we want to add a couple features to the language, but without modifying this underlying abstraction as much as possible. So we came with, okay, so now I can have optional parentheses, but that doesn't change the representation. The representation of the code is the same, right? So what macros are allowing us to do is to represent code as data and then have macros that get this data and transform this data and emit more data. And operators are the same thing. They have the same representation. It just happens to change the function name, okay? But in practice we don't write those nodes by hand. What we do is this. So here's how you can implement unless in Elixir. Unless in Elixir is just a macro. It's not a keyword. It's not anything special. And what it does is that, so quote is something that can generate those AST for us. So what we say is that, well, we are receiving this data and we want to, that represents code, and we want to convert it to something else, okay? And then we convert it to a negated if, which is unless basically is. So we started to go into this direction, okay, we can still have the natural syntax, but we can still have macros starting to get the both features that we wanted. And then at the end we said, okay, and in order to guarantee explicitness, every time I want to use a macro, I need to explicitly require the module that defines it, right? And that means that macros are lexical, and that's extremely important. There is no way in Elixir that you can have a file injecting a macro in some other file that is going to change how that other file is compiled. That cannot happen. It's lexical. So before you use a macro, there is going to have something above that line, okay, somewhere in that file above that line that says, hey, I am using this module or I'm requiring this module. And it keeps it explicit and bounded to a single file, okay? And not only that, macros, they are compile time only. After you compile your code, it's not going to, the system is not going to change and start meta-programming things at runtime. You know, when it's compiled, it's over. I like to say that this is like sane insanity, right? Like you can do a bunch of crazy stuff, but it's bounded to some particular properties. It's bounded per file, and it's bounded to compilation time only. And then, hooray, right? When I defined this, when I was done with this meta-programming with Lago Lang, we had not only how I wanted the language to look like and how I wanted to do meta-programming, but I knew how I would develop the language. Because if we have those properties, we could use Elixir to implement Elixir itself. And that's pretty much what happened. So if you go to the Elixir code base, the huge majority of the standard library is written in Elixir itself, okay? And it's thanks to those properties that allow us to bootstrap the language and write a lot of the language in itself. So at the beginning of 2012, I went to my co-founders at Plataformatec and I told them pretty much this story. I say, hey, I think there is a chance we can build this new language that is going to focus on productivity, extensibility, and is going to leverage the Erlang virtual machine. And I think that is something that, you know, as concurrency is becoming more and more important, it's something that we will be able to start to use in the next, you know, 3 to 5 years. And I went with this proposal because I wanted them to allow me to work part-time on Elixir initially. And we all accepted the proposal. And, you know, and that led to the time that we are kind of like familiar today, right? So Plataformatec accepting to, you know, to work on Elixir as part of the company was also really important because we started to put company resources into it as well. So for example, the logo came, you know, from our designer at Plataformatec. And thank God I was not the one designing the logo because maybe we wouldn't not even be here at all, right? So, and then I started working on it part-time, and then books started to come out. Authors were working on books, and then I started to work on Elixir full-time, which I have been for like 3 years, probably more than that. And we reached Elixir 1.0 in September 2014. It was right after the first Elixir conference that happened in Austin. And at the time, I already had more than 180 contributors. And we had 3 books almost out. The books that were ready, they were just waiting for us to say, Elixir 1.0 is out, okay? And then that was in 2014, and now we just got in January, kind of like a celebration of the 5 years. We got Elixir 1.4 out, and we have more than 520 contributors, so thank you for all your contributions. And this is unfortunately only the code contributions, but I know that a lot of you are contributing to the ecosystems in a bunch of different ways, right? And we're very thankful for that. One of those ways is actually, for example, packages on HexPM. HexPM started as a package manager for Elixir and became the package manager for the whole Erlang ecosystem. And we are reaching almost 4,000 packages. And I know there are events happening now around the world. We have events happening in Japan, Mexico, South America, other events happening in Europe. So those are great. And then we have books, podcasts, online classes, a bunch of different ways to learn the language. So the community really stepped up and is bringing the much needed diversity. All right. So that's Elixir 1.4, and then the next step is going to be Elixir 1.5. And we are going to talk it very, very, very briefly a little bit later. But one of the things that in those 5 years, one of the things that I still like the most, it's exactly to be here at Elixir conference. Because since the beginning of Elixir, when we started to have like a working version, I started to go out to other conferences and start to talk about Elixir or to go to meetups. And there, I always have to assume that the audience never heard about Elixir at all, right? And which is the difference here. Here, you know, I hope everyone here heard about Elixir at least once. Otherwise, you should go to the Meet forum because you are in the wrong room. So, and that's great because I can talk about things that I wouldn't be able to talk otherwise and explore concepts in different ways that I wouldn't be able to do otherwise. So what I want to do, we are 20 minutes in, okay? So what I want to do is that for now I want to explore what is Elixir, and that's going to be the ElixirConf version. And then later I want to talk a little bit about what is happening in the future and just glance through that very quickly. Okay, so what is Elixir? And this is the ElixirConf version, right? So as I was saying, if I was in those other events and they ask me and I'm introducing Elixir, I would tell them like, Elixir is a functional, concurrent, and distributed programming language for writing maintainable and scalable applications, which is the description that we have on our website. And you know, it's a very reasonable description. But for the conference, I want to make a twist. When I ask, what is Elixir? What I actually want to answer is like, what is Elixir made of, okay? So the goal of this part of the talk is this. So I want to talk about those three components, data types, modules, and processes, with the hope that if you understand how those three concepts exist and how they relate to each other, you have all the background necessary for understanding how your software actually works in production. So we're going to talk about how Elixir works, not the compiler, not the syntax. We're going to talk about the runtime, how Elixir works at the runtime, okay? But before we explore those three things here, okay, we have those three distinct things. Let's take a step back, okay? I want to talk about some mutable OO language. It can be whatever language OO. And the reason I'm doing this step back is because it's very likely that 99% of you, it's coming from a OO or mutable language background. So I have some snip of code here, which is saying dictionary.store. So we have a dictionary variable that holds a dictionary object, okay? And then I'm calling the store method, passing two arguments, the key and the value, okay? And we can say here that the dictionary as an object, what it does is that it encapsulates the state, okay? So it has some state that is the internal dictionary, which is this internal key value store representation, okay? And the store is the behavior that is associated to that object, right? So objects, they couple the state and they put state and behavior together. And that's exactly what we can see in this piece of code, okay? So that's what we get with objects. However, if it's a mutable object-oriented language, we have another concept in here, which is exactly time. Because at the moment, so I have a dictionary. At the moment I say, hey, I want to store this key and this value, that thing is going to mutate. It's going to change itself and have that key stored in itself, right? And the reason that I say that this represents time, because from an external perspective, right? Something happened that thing changed. That thing was not static, right? Something happened somewhere that made that thing change. And that can even lead to things like loss of information. So for example, imagine that the key that we are trying to store, it already existed in the dictionary with a different value. When I run this operation here, when I call this method that mutates the dictionary, it's going to change the key to a new value and information is lost. There is information now that just disappeared. Right? It's not going to be referenced anywhere, and then we're going to have a garbage collector that is going to go and remove it from your system, okay? So there's clearly time passing here because things are changing, right? And what makes it hard to understand software in those cases is because every object has its own notion of times, right? So in a lot of languages, in some languages, the strings, they're immutable, but in a lot of languages, the strings, they're mutable, which means that when I'm passing the key and the value, they have their notion of time as well. So as you create a bunch of different objects, each of those can mutate, right? And each of those can mutate on their own. So each of them have their notion of time. And that's what makes it, that's what adds complexity to software, right? Because you can have all those things that can be changing at any time at seemingly unrelated ways, okay? So what happens in Elixir is that those three things, the state, the behavior, and the time, they are completely put apart from each other, okay? We put them into those very three distinct things. So we have the data types, and they represent state. So we use the data types to represent the state, represent the data, but they are immutable. We cannot change them. So they are great for modeling the state, but you know, we cannot mutate them. They don't have this notion of time tied to them. And then we have modules, which is where we write our code with functions, and that's where we put the behavior. And as we're going to see, there is no data intrinsically associated to the behavior. Everything that the behavior needs to have to work, it's passed as an input, and everything that the behavior needs to return as a result of that work needs to be given out as an output, okay? And then we have the processes, which kind of puts everything together and adds this notion of time. So here's how we would write that code, right, in Elixir. So we need both data and modules. So the data here, for example, now we don't have this implicit data that is passed around. We need to pass the map, which is our dictionary, which is how we call dictionaries in Elixir. We need to pass it explicitly as an argument, right? And each argument is going to be just that, just data, okay? And the behavior, it's defined in modules. And in Elixir in particular, behavior are identified by the module name, the function name, and the number of arguments that that function expects. So here our behavior is map.put/3, which is the map, which is the put function in the map module that expects 3 arguments. And that's it, that's data and the modules together. And in here, we don't have time, we don't have mutability, okay? If we want to have mutability, if we want to have time, we need to bring processes into the equation, okay? And processes put those two things together, because here's the most native way of starting a process in Elixir. We call it spawn, and we pass 3 arguments. So the first is the module name, the second is the function name, and the third is the arguments that are passed into that module and function. So you can see here that when we start a process, we need to give the behavior that we want that process to execute, right? So we are giving the behavior to the process. And the arguments that we pass is the things that represent the data, right? And that's our state. So when we start a process, it's putting those two things together, okay? And then if you're going to look at the code, it can look something like this, right? It's a loop function that has the data that belongs to that process, and the code, the behavior here, in the middle, which runs sequentially, okay? So I want to do a very quick pause to just say something. The sequentially part here is extremely important. So sometimes someone says, isn't the do, so code, a lot of the code in Elixir, it's wrapped between the do and the end words, right? And then sometimes I have the question, isn't do like a weird word isn't it like an imperative word in contrast to functional? And my answer is usually no, because what do is about sequence. Imperative programming is about showing progress through the mutation of state, right? And that's not what we are doing here. So the do is there to tell you that the code that you write there is going to be executed in the order that you write. So exactly what I wrote here, code runs sequentially, okay? And even if you look at other languages like Haskell, the do there is not about imperative programming necessarily. It's about running the instructions that are passing sequentially. And this mirrors exactly that, how we write Elixir code. Okay, so we have those processes, they have the data, and they have a bunch of code that runs sequentially. So at the end of the day, okay, we can say that processes, they own the data, all right, and they run the code, which is the behavior that is specified by modules and functions, sequentially. And we know that we do not have only a single process when we run our code. We don't have only one of those. We have a bunch of them running side by side. And that gives us the idea of concurrency, okay? But you may ask, okay, so that makes sense, but what about time, right? We said that processes are the one responsible for introducing time. And where is time being added here, right? If we have a bunch of processes running side by side concurrently, completely isolated from each other, do we have a notion of time? We have this question, this thing, which is, if a tree falls in the middle of the forest, does it make a sound? Right? Which is, which means for us, like, if we don't have anything observing if there is a sound or not, does it actually matter if it makes a sound or not? Right? So if you have a bunch of processes that they are all running at the same time, but they don't really know about each other, what does it mean, right? Do we have time? And I think that the answer is no, right? We don't have time because they don't have any other reference besides their own, okay? So when we think about time in Elixir, and in particular with processes, the reason we do that, the way we do that is that we do with message passing, right? So I have two processes, and then I send a message to another process, and that process sends me a reply back, right? So modeling, now I have this notion of time because I know that in order to get that reply, I sent a message first. So there is a very good relationship between cause and consequence. And that's what I like about message passing, is exactly that it has this built-in idea of cause and consequence to it that makes it easy to reason about time, the system, how things are progressing as they communicate with each other. And remember that at the beginning of the talk that I said that one of the things that I like about the Erlang virtual machine is that we have the same abstraction that is used for concurrency and distribution, right? And it happens that message passing, it's a very good way of modeling distributed systems as well, at the low level at least, right? And that's the same abstraction that we're using. And the reason why this matters, the reason about having good ways for modeling time and modeling concurrency, the reason it's important is because without a good mental model, concurrency will be constrained by Amdahl's law, okay? So what is Amdahl's law? Amdahl's law says the following. Amdahl's law calculates the potential speed up that you are going to get in your software as you increase the number of cores, okay? So here, for example, we can see the lines here. So if 95% of my code can run in parallel, so the parallel portion of my code, if it's 95% of my code, we can see that as we increase to, 1,000 cores, 16,000 cores, we are getting benefits, right? However, if only 50% of my code is actually can actually be parallelizable, you can see that after 16 cores, we pretty much don't get any benefit anymore, right? Like when we have 4 cores, we're already like 80% there, and then when we get to 16, there's pretty much no reason to go forward, right? So, it's still not some magic thing that you're going to choose a concurrent language, or the language that you're using today, it's going to add threads, right? That's not enough. You need to have a good mental model, because if you don't have a good mental model, you're going to be constrained by this. So we need to have good tools that allows you to look at a problem and say, hey, I know, I can understand, and I can model this problem using tools that allow me to leverage parallelism, that allow me to leverage concurrency. This way, when we get to use 64 cores, 128 cores, right, we are still getting a reasonable speed up, right? But processes, they go way beyond concurrency, okay? We already hinted about distribution. So when to create processes, right? So this is a very good time to do a very important disclaimer. Processes in Elixir, they are not code design tools. You don't create processes to say, oh, like I have this new concern in my application or a new concern in this domain, I'm going to create a process to manage it. No, processes, they are runtime, they are tools to reason about runtime properties, to reason about concurrency. So when we create processes, if we need to have a mutable state, that's a good thing, which is the example we have been talking about. Or even if you don't want to have mutable state, you just want to have concurrent execution. You want to start 8 processes where each of those is going to fetch a different URL, and they never actually communicate between them, just for concurrent execution. However, we also create processes when we want to handle and isolate failures. If there is something that you need to execute and you actually don't care if that thing fails and succeeds, you start a new process and have it run that. And then, if it's over, it's going to be the tree that falls in the middle of the forest and nobody's watching it, right? It's over and it's done. I don't care about the result, okay? or we also use them for modeling distributed communication. Okay? So at the end of the day, we can come back and look here and say, you know, those are the three properties, the three primitives that we have in our Elixir systems, and that's what the runtime uses to work with and run your code. Okay, so we have the data types that are state, immutable state. We use that to represent the state. Okay, we have a variety of data types to make this representation of state straightforward. And that's why we have pattern matching, right? Which is put the state up front. Okay, we have modules, which is where we put the behavior. And we have processes that allow us to model different things, including time, right? And that gives us concurrency, it gives us distribution, it gives fault tolerance. Processes, they're really beautiful, right? Because it's a single abstraction with a couple of primitives around that was able to model those concerns, okay? From the design perspective, I found those things really pleasant, right? Because we don't have a different concept for each. There's the downside, which is overload of a meaning, overloading of a tool, right? But when employed correctly, finding the proper trade-off there, it's really exciting. And I think processes which come from the Erlang virtual machine, it's exactly one of those. All right, so that's what is Elixir, okay? The ElixirConf version. And now what I want to do is that I want to move to the last part of the talk, where we're going to say a little bit what is coming in the future. So, Elixir 1.5, good news, there is nothing big planned. Right, so I really like the Elixir 1.4 release because it was our smallest release since we had 1.0. And it kind of reveals the direction we want to be in. And I've been saying that since Elixir 1.0 is out. Like I like to say there are two kinds of 1.0 releases. There is one which is, we're just getting started, right? And there is the one like, hey, this is the deal, right? Of course, we're going to continue improving things and continue moving forward. But that's pretty much the deal, right? So when we look at the previous slide with the data, the behavior, and the processes, right? We already added the extensions that we wanted. So let me roll back even. We made a bunch of those things to be more Elixir-like. So for example, in Elixir we have protocols, which is about doing polymorphism on top of data types. It allows you to write code like this, hey, I don't care which data type you give to me. I just care that it implements this particular protocol. This was one addition that Elixir brought to the Erlang virtual machine. So it kind of like, well, the data types and modules and process, yes, they come from the runtime, they come from Erlang, but we improved them and add a little bit of our own spice to it, right? So in data types, we add the protocols. In modules, we add a metaprogramming. So the metaprogramming that we do that on top of the behavior. We do that when we are defining the modules. And that's why it's compilation time only, because after the module is compiled, it's over, right? And the one that we actually, let's say that we improved the list was processes. By Elixir 1.0, our the biggest improvements that we have done at the process level was exactly to add tasks and agents. And just later on that we started to play more with this process area, okay? So for example, there's GenStage and Flow, which I'm going to talk about soon, which was adding a new behavior to processes and how processes can exchange data. But anyway, the point is that we are doing small increments, right? There are no big revolutions happening here. And what it happens is that we are going to have releases where, they're just maintenance releases. We are fixing bugs, we are adding some small features, some small properties, and that's it. So and that means also that there is a lot of space for contribution as well. So if you go to the issues tracker, right, you're going to see the issues there. They're all going to be categorized by application, by their difficulty, if it's a discussion, if it's something that is already to be implemented, and you can join the discussion either in the issues tracker or in the Elixir Lang core mailing list. Okay, so this is good news, really. Like we are keeping it. This release is going to be another small one, so we are going to We're continuing doing small steps. However, it doesn't mean that it's over and not going to see nothing different coming to the language. We are still exploring things, and they are going to come from time to time at their own pace. And one example is exactly GenStage and Flow, right? So GenStage and Flow, we're actually working on it for 2 years, trying to find a good model for modeling the problem we had at hand. So what is GenStage and Flow for those who are not familiar? So GenStage is a new behavior. It's a new thing that we use to model processes. And it's all about exchanging data between processes. Okay, so it's about optimizing this case where processes, they need to be communicating large amount of data between them. It's also about back pressure. So if you need to contact with an external system, GenStage gives you tools to signal how much data you want to consume right now. And Flow is something built on top of GenStage that allows you to express computations like map, reduce, filter, sort. And we are going to get those computations and automatically parallelize everything and use all of the cores in your machine, right? So as I said, those are improvements that we are doing more at the process level, those abstractions built on top of processes. And we worked on it for 2 years with the original goal of it being added to Elixir. But at the beginning of this year, we realized that we are going to keep those as separate projects because they kind of created a life on their own. And we brought some of their lessons, some of the things we learned here, we brought them directly to Elixir. So Elixir 1.4 has a feature called Task Async Stream that gives you a potentially infinite source of data, and then you can control how many tasks you want to run from that source of data at the same time. So if you have, for example, or even a finite source of data, imagine that you have like 100 URLs to the same domain, and you need to fetch all of them, and you want to fetch them in parallel, right? You cannot start 100 at the same time because it's very likely that whatever they are using, like a proxy or something, is going to say, hey, no, what are you doing? Why are you trying to open 100 connections, right? So you want to keep that bound. You want to say, okay, I want to open 8 and 8 at a time. And this is something that, initially we wanted you to use GenStage and Flow for that, but we learned some lessons here. We could bring that directly into Elixir while keeping GenStage and Flow apart, okay? So, but for all purposes, GenStage and Flow, it's done. It was a research project that we were at it for a while, and it's done. Right now, it focuses on a single machine, so it focuses at concurrency. Eventually, we want to make it distributed, but that's a story that's going to come much later, okay? Not now. So if you want to learn more, a very good starting point is the announcing GenStage blog post. I also gave a keynote presentation at Elixir Conference United States last year that was talking about exactly GenStage and Flow. So those are 2 very good introductions. Another project active research project that we're working on is to have UTF-8 atoms. And so in Elixir, we always favored Unicode, right? It was one of the reasons I actually created Elixir. I wanted to type my name without having to do a bunch of weird dance with characters. So, but atoms, they still, until Elixir right now, they are still Latin 1, right? So you cannot have the euro sign on an atom. You cannot write Japanese characters, okay? But I'm really glad to say that we have made some really good progress in here. And there is a chance that by Elixir 1.5, we'll be able to write code like this. You'll be able to say test, that's hello world, I think, in Japanese. And it's asserting that we have a atom written in Japanese. And actually the reason why, so here we actually have 2 features because since tests, they become function names, the first feature that we need is to be able to write function names as well in Unicode. And then we have the atoms themselves. And it's really funny because when this problem became apparent to me when someone opened up an issue and they said that they could not write a test exactly with or the pound sign or the euro sign in it. So they could not have in the test description those characters. And then they realized, well, that means that, for example, if someone from Japan is trying to write their test description in Japanese or having Japanese characters, they simply cannot do that. And that's very likely a horrible experience. So we've worked together with the OTP team. So there is a huge discussion you can go to the link about changing how atoms are stored in the compiled code. And that is merged, that's going to be part of the Erlang 20 release, which means by Elixir 1.5, if you figure out all the details, if you're using Elixir 1.5 and Erlang 20, you'll be able to use UTF-8 in your atoms initially. So you can't have UTF-8 or Unicode things in your functions yet, but so you cannot use like the pile of shit emoji for a function name, I'm sorry, but you can do that for atoms and other things. Something, and that's in progress, and we are hoping that we are getting there, okay? By 1.5, which should be by June, July, or something like that. But then we have other ideas that we are exploring, and they are very early research. One of them is data streams and property testing. So in Elixir, we have this thing called streams, which allows you to lazily generate data, right? But the way we use streams today, many of the ways it's mechanical, right? Like you need to go and build a stream yourself. And what we are thinking is, what if we have data streams? If we are able to say, hey, I want you to give me a random stream of integers. I want you to give me a random stream of strings, of binaries, of whatever, of positive integers. Okay, so so what if we have data streams in the language? And what if we not only use those data streams to generate data, but also to validate the data? It's kind of like a data specification. If you are familiar with Clojure spec, they have very similar ideas in there. So the idea is like, what if I can specify like the shape of my data, and from that I can validate external data. I can validate if external data conform to this specification, this format I described, and I can also use it to generate data when I want. If we have that, we can have something like property testing. And the idea with property testing, so in Elixir we have the string module, and we have this function called starts with, which is check if a given string starts with the other string, okay? And when we implemented this function, I need to come up with examples out of my head. Right? I need to say, okay, I'm going to use foo and bar to test those strings, and then we create some random examples, right? But what if the examples I'm coming from my head, they're not actually good? What if I'm missing some scenarios? What property testing allows us to do is that instead of coming up with specific examples that we write in our tests, we define the property that we want this thing to exhibit. So I say, if I have two random strings, okay, and I concatenate them, it should start with the beginning of the first string in the concatenation. That's the property that I want this code to exhibit, okay? And that's going to take the burden out of us of generating all those test cases, which is really excellent. But to me, and that's a very good appeal already for property testing. But the most exciting thing I think about property testing is because it's actually a very good design tool. And I chose this example on purpose because we are trying to figure out at some point if the string starts with should accept empty strings. So what happens if I have the empty string as first argument and an empty string as second argument? Is it true or false? Should we allow that? And then to solve the problem, we actually pinged Thomas and said, hey, if you were to write a property for this function, which property would you write? And then he wrote this property and he said, according to this property, we should support empty strings, and it should return 2 if I'm asking if an empty string starts with an empty string, because that's the simplest property that I can come up for this. And they were like, done. It's going to accept empty strings. And then we merged the pull request, and we lived happily ever after. So, but again, very early research. We're going to have, when we have more information, we're going to let you know, okay? Some things that we are also exploring, and this is Axel. He's doing that as part of his master thesis. So again, GenHTTP, and it's very early research. And what we wanted to do here, so we have a bunch of HTTP clients in the community, okay? But all those clients, and they do the job fairly well, okay? But all those clients, they try to be a complete solution. They come with their pool, they have their own session storage, they try to do everything, they try to bring everything, okay? So, but sometimes we do not need to bring all that complexity. Like sometimes we want to have a smaller abstraction to start from and then build on top of that. And that's exactly what GenHTTP is about. So GenHTTP is about modeling HTTP at the process level. So all it does is going to say, hey, you can handle those things at the process level, and that's it. You can think it of a wrapper around the low-level GenTCP, and then it's up to you. If you want to have the same process starting 10 HTTP connections, you can do that. If you want to have a pool, you can do that yourself, okay? But the goal here is to have a better foundation that is more flexible, that everyone is going to build on top, okay? Because we don't want to go into a scenario that, you know, every year we have a new HTTP client of the year, okay? That's not what we want to go to, and we want to have a unified foundation and allow everyone to build what they want on top of that. And finally, there are two other projects that, so we have this Google Swarm of Code where we have students working on projects, and we had a break last year, but this year we are back, and we have two projects that we are hoping they will get accepted. The first one is the Elixir formatter. So the idea is that we're going to have a tool that is going to go at your code and format it according to certain rules. So we don't need to have style discussions on what is preferred, what is not preferred. So again, this is a project that we are going to start as a prototype, trying out some ideas in the Google Swarm of Code. And you know, all those ideas, I forgot to say the disclaimer, but all those ideas, I may be talking about them next year, or I may be talking about them in 5 years, or I may be talking about them never. Okay, so again, we are looking to those things and we are exploring them, but there is a lot to be validated still. And the other Google Swarm of Code project that we are interested in is the language server protocol. So language server protocol is an idea that came from Microsoft, and we have a bunch of editors today, right? And we have a bunch of programming languages, and we want those editors to support all those different programming languages, and each language and each editor has its own combination of tools and things. So we have like a M per N matrix of protocols and things that they use to communicate. The idea of the language server protocol is to have a common thing in the middle that all editors are going to talk and all languages are going to talk. So we don't need to re-implement editor support for each editor in each language. And that's another Google Swarm of Code idea that we are hoping it's going to get accepted, and we'll be able to see some advancements throughout the summer. All right, so that's like what we have been thinking on lately for the long term rather than the short term. The short term, again, is in the issues tracker, in the main list discussions. It's always there. Development has always been clear and explicit. And that's it. And finally, I want to thank Plataformatec. So Elixir, you heard this story. So Elixir was built and designed since 2012 at Plataformatec. All right, so if you're thinking about adopting Elixir and you're interested in coaching, any kind of design review or custom development, let me know, hit us up. And yeah, so that's the talk about Elixir, and thank you for hearing.
So we're going to take some questions over here. Thanks so much, Jose, for that. That was really awesome. But if anyone has any questions, we have a mic. We have a mic up here, and I can come meet you as well. So, any questions? Hands raised if anyone wants to ask.
All right, we have.
Okay. Do you want to come over here, or I mean, I'll run around and catch you. So.
I wanted to ask about the property testing. I wasn't sure about the test. There was one test, and you write the string streams.
Yeah.
How many different tests are running then?
Yeah, so property testing tools, and Thomas will even be a better candidate for answering this question, but all those things, they are configurable. You can say, I want it to generate 20 samples, or you can give it a time-based thing. You can say, well, I want it to run for 1 second. And all those things, it's going to be, you can configure it at the command line level, for example. So for example, in your machine, you may want the thing to generate 10 samples and that's it. But for our building productions, you may want to say, hey, I actually want to make this thing time-based and have those things try for 1 second to generate data to really hammer out this function. So you have different parameters that you can use to control, and those things will be flexible enough that you can control how much or for how long you want those things to happen, depending on the environment that you run. Cool, thank you for the question.
Does anyone else have a question? Super. Here, we have about 5 minutes for questions, so.
I just want to add to
Thomas.
José.
Yes.
Yeah. So this is property-based testing is already there. So if you want to kind of experiment with it, just download EKCX and Quick Check Mini, and then you can do these kind of simple properties where you specify your code. Instead of writing a test case, you set something more general about your code, and you generate your test cases. And then the matter of how many, that's just a parameter, right? And you can, as José said, put that in there. The difficulty is to come up with the properties. What should my code do? But that's also the nice thing of it, because it makes you think about your code. And that's something which you really can appreciate if you've done that for a while.
Yeah. Thank you, Thomas.
Thanks. Does anyone else have a question? Going once, going twice. All right, so that's a wrap. So I think we have, yeah, everyone, another round of applause for José.